Moving ahead, so now we will try to prove our second trigonometric identity, that is sec square theta equals to 1 plus tan square theta. So to do that, first of all, let's quickly remind the trigonometric ratios. So as we have already discussed that in any right angled triangle, there can be only six possible ratios. First one is sine theta, that is the ratio of perpendicular to hypotenuse, and its reciprocal cosec theta as hypotenuse to perpendicular. Similarly, cos theta equals to b upon h and sec theta is equals to h upon b, and tan theta is the ratio of perpendicular to base and cot theta is the ratio of base to perpendicular. Okay, so moving ahead, again we will be using the Pythagoras theorem to prove this. So let's mark this as equation number 1, and this time we will be dividing the equation both the sides with b square. So moving on, we will have h square upon b square equals to b square upon b square plus b square upon b square. This will become 1, and we will have h upon b whole square equals to p upon b whole square plus 1. Now, if we look and observe closely, h upon b is nothing but the value of sec theta, and p upon b perpendicular to base is the ratio of tan theta. So substituting the values, we get sec square theta equals to tan square theta plus 1. Rewriting the equation, we have sec square theta equals to 1 plus tan square theta. And this is how we prove our second trigonometric identity.